Welcome to 3.2, Part 2, where we explore synthetic division. This is just an alternate to polynomial long division that I can almost bet a lot of money that you will like a lot more. It takes way less time and it's a lot easier. But the only thing with synthetic division is that it's only for dividing by something that looks like this: x minus 3, x plus 7, some linear binomial. So if your divisor is larger than that, then we can't use synthetic division. We are going to do 3 examples of synthetic division, and it's actually kind of fun. So let's start with our first example. All right, this is the same, actually the first 2 examples will be the same 2 from the part 1 video where we did polynomial long division. I wanted to pick the same 2 examples because I want you to see that we'll get the same answers. So we can see that our divisor here is of the form x minus 2, x minus a. The lead coefficient here is 1. So what we're going to do is we're going to look and see that it's x minus 2. So when we set up our synthetic division, there's a positive 2 in this little corner. It's the opposite of what we see here. So it's going to be a positive 2 in this corner. Then we're going to go through and make sure we don't have any like missing terms or gaps. And we don't here. This is the cubic term, quadratic, linear, and then constant. We have no skips of our exponents at all. So we're going to write the 4 coefficients here, the coefficient of each term. So our first coefficient's 1, then a 4, then a negative 5, and then the constant is negative 14. So we'll set that up to the right: 1, 4, negative 5, negative 14. Then you skip a line, draw a line. I say that as if I'm writing on like lined paper. Okay, the process is that the first number, 1, goes straight down and goes below the line. Then we repeat the same process. We multiply 1 times 2, and we write it here. So we're going to put a 2 here. The second step of the process is combine vertically. I don't like saying add or subtract because the numbers could be positive or negative, so I'm saying combine them. So we're combining a 4 and a 2, and we write it down here. So we put a 6 down here. Then we repeat the process. The process is multiply by the number up in the corner box, and then combine vertically. So we multiply, we get a 12. Combine vertically, negative 5 and a 12 combines to a 7. Repeat the process. 7 times 2, 14. Then combine vertically. Negative 14 and 14 is 0. Then you put a line here. This separates the quotient and the remainder. So this part right here is the coefficients of the quotient, and this part right here is the remainder. Let's write out what the quotient is. So we can see that we started with a cubic and then we divided it by an x to the first, a linear. So we essentially slice this cubic down by 1 degree. We slice the 3 down to a 2. So our final answer, this is the x squared term. This is the coefficient of the x or linear term, and this is the constant, meaning we write our final answer as 1x squared plus 6x plus 7. So that's where the 1, the 6, and the 7 go. And again, our polynomial started as a cubic and we divided it by a linear. So our quotient is a quadratic. Then this has a remainder of 0. All right, let's write our final answer looking just like this. So we write our final answer, our original polynomial, p of x, which is up here, can be written as the product of our divisor, d of x, and our quotient, q of x, plus our remainder, r. So p of x can be written as the divisor, what we divided by, multiplied by our answer, the quotient, q of x. And then if there is a remainder, we'll put plus the remainder at the end, but in this case, there is none. So we can write p of x, which is x cubed plus 4x squared minus 5x minus 14, equals the product of d of x, the divisor, in this case what we divided by, in all cases what we divided by, times our answer, the quotient, x squared plus 6x plus 7. And then we can put a plus 0, but I'm not going to in this case. So the synthetic division part is right here. This is the synthetic division. And this is just another way to divide polynomials so long as our divisor is a linear binomial, and it was. And then it gives us our quotient, we put a line, and our remainder. This is the same as in the other video. It's just a way to show our answer. Since we're dividing polynomials and we get an answer, we can say that that original polynomial was what we divided by times what we got, plus any remainder. Here's example number 2. So we see that we're dividing by another linear binomial. So what we do is we're going to take the opposite of that plus 1. So we're going to put a -1 in this corner box up here. That's the number that we multiply by each step. Then we take a look at our original polynomial p of x, and we can see that we have a quintic trinomial. We're missing the quartic term and the quadratic term and the constant. So we can put all of our coefficients. The coefficient of the quintic term is never -1. There's no x to the 4th term, no quartic term. Our cubic coefficient is 7. We do not have a quadratic term. Then our linear coefficient's -1, and our constant is 0. Again, I need to put placeholders for every term that you skip. All right, then we skip a line and draw a line. The synthetic division process goes like this. You take the first number and bring it down. Then it's the same two things, which are multiply and then combine vertically. Then you repeat the process. So multiply, -1 times -1 is 1. Then we combine vertically. 0 and 1 combines to a +1 down here. Then we repeat. Multiply, 1 times -1 is -1. Then we combine vertically. 7 and -1 combine to 6. Repeat. 6 times -1 is -6. Then we combine vertically. 0 and -6 combine to a -6. We multiply. -6 times -1 is 6. Combine vertically. This combines to a 5. One last time we multiply. 5 times -1 and combine vertically. Put that line there. This is our remainder. These values right here are the coefficients of our quotient. All right, so here's our quotient. Here's what it's going to be. We started with a quintic polynomial, degree 5. We divided it by an x to the 1st, a linear binomial. We cut this 5 down to a 4. So this is the x to the 4th term, x to the 3rd term, x to the 2nd term, x term, and then the constant. So our quotient, q of x, looks like -1 x to the 4th plus 1x cubed plus 6x squared minus 6x plus 5. And then we have a remainder of 5 at the end. So this is our q of x. Here's how we can write our final answer. We can say that our original polynomial, which was -x to the 5th plus 7x cubed minus x, can be written as the product of the divisor, which was x plus 1, times the quotient, and then we add on the remainder here at the end. All right, so this is the synthetic division right here. Really, it doesn't include this yellow piece right here. I'm just showing you what we ended up getting, but the synthetic division work is here in blue and white. And then our final answer was this quotient and remainder. And this is a way that we can write p of x equals d of x times q of x plus r of x. Here's our third and final example. This is going to be one where our a value here, the constant in our linear binomial, is a fraction and not an integer. And so we can see that it's -3/2, so we're going to put a +3/2 in that corner box. And then we can also see that we're skipping the quadratic term here. We go right from cubic term to linear term, so we're going to need a placeholder in there. So we're going to have a 4, then a 0, then a -1, and then a 2. Skip a line, draw a line, and bring down your first number. That is the start of the synthetic division process. All right, then we multiply 4 times 3 halves. If you need to do that off to the side as like a 4 over 1 times 3 over 2, feel free. You can either multiply straight across, so we'll get 12 over 2, which is 6, or you can cross cancel the 4 and the 2, which I like to do. They can both be divided by a 2. So we'll get 2 times 3 over 1. So the answer is 6 either way. So it's up to you. All right, so then we combine vertically. 0 and 6 is 6. Then we multiply 3 halves times 6. I'm just going to write these out. I guess I did the other number first there. Okay, so 6 times 3 halves. I'm going to divide these both by 2, so we'll get 9. Then we combine vertically. -1 and 9 combine to an 8. So I have to do an 8 times the 3 halves. Why am I putting all these numbers over 1? Like, why did I put 4 over 1, 6 over 1, and 8 over 1? Because if I don't do that, sometimes students will multiply the 8 times the 3 and the 2, and that's not what we're doing. The number's not 8 over 8, it's 8, which is 8 over 1. So I'm just showing that we can write any integer as itself divided by 1. All right, that was a little tangent there. I'm going to divide the 8 and the 2 both by 2. So 4 times 3 is 12 over 1, which is 12. Then we combine vertically, and we'll get a 14 at the end. That's our remainder. So our final answer here to answer for what the quotient is, again, we started with a cubic, and we divided it by a linear, so it cut the degree down 1 in our answer. So this is a quadratic trinomial here. So it's 4x squared plus 6x plus 8, and the remainder is 14. So the way we can write this nicely at the end is that our original polynomial can be rewritten as the product of the divisor, this guy, what we divided by, and our quotient, which was 4x squared plus 6x plus 8. And then it didn't fit in evenly, right? So this x minus 3 halves is not a factor of this because there was a remainder at the end. And that remainder is 14, so we'll do a plus 14. Now, what does this really mean, all this down here? Well, it means that if you wanted to multiply this by this, the blue times the yellow, and then add 14 at the end, you would end up with this original polynomial in white. So we are dividing, and a way that you can check your work is multiplication. It's just how we can check our division work. So if you'd like to go through, that is a way you can self-check and see if it is correct.